on ranges and proving grounds, in laboratories and arsenals, across the continent and overseas. The United States Army Research and Development Team is in action. Army R&D has one primary objective: to maintain superiority, to prepare today for the enemy we may face tomorrow. Under the recent Army reorganization, the materiel responsibilities formerly assigned to 6 different Army technical services, the Quartermaster, Ordnance, Chemical, Signal, Engineers, and Transportation, were absorbed by the new Army Materiel Command, the AMC. This brought the bulk of the Army R&D program under one unified command, centralizing control and pinpointing responsibility. This unification will speed the development of weapons and equipment. It will also make possible a faster logistics response. Most of AMC's installations and activities have been organized into subordinate commands in which authority has been divided as to function rather than service. An improved management program called Project Management has been initiated. Project managers with overall decision-making responsibility and complete authority have been placed in charge of many key materiel programs. Under the project managers, valuable time and money will be saved and a better product assured, not only during development, but on up through procurement and distribution of each essential item of equipment. To show some recent project management accomplishments, as well as some general items, here is a special progress report from the files of the Army Materiel Command. More muscle and hustle for the combat engineers. That's the purpose of the new Universal Tractor Crawler, known as the UET. One unique feature of the UET is the hydro-pneumatic suspension system controlled by the operator. Elevated to sprung condition, the vehicle runs smoothly and comfortably on or off the highway at convoy speeds, easily able to keep up with armored personnel carriers. Designed and engineered for utmost versatility, this Husky vehicle is light enough to be air transportable and rugged enough to handle the toughest construction jobs. It can perform heavy work by means of the self-loading ballast bowl, which, when filled with dirt or other ballast, can double the weight of the vehicle. This additional weight provides the UET with a drawbar pull equal to the AVD7 Caterpillar tractor, which is twice the weight of the empty UET. The hydraulically operated gate at the rear of the compartment serves as an ejector mechanism. It permits the machine to spread its load while it is in motion, being used as a scraper or in other earth-moving activities. The UET also has the bulldozing capabilities of a D7 conventional tractor. Located in the rear of the vehicle are the 250 horsepower V8 liquid-cooled diesel power plant and the operator's seat, which provides a clear view forward during scraper and loading operations. The UET has a sizable cargo capacity and can perform at relatively high speed, even over rough terrain. The Universal Engineered Tractor Crawler will be used as forward echelon and battlefield equipment. It carries the lateral protection of an armored personnel carrier. In addition to its high performance over land, it can ford streams with ease. It also has a swimming capability of between 3 and 4 miles per hour. This versatile high-speed vehicle will be the primary transportation of the combat engineer units to which it will be assigned. It easily transports a squad, complete with equipment and necessary supplies, delivering them fresh and fully equipped. This testbed prototype has established the feasibility of the UET. Engineering test models are now being tested, and the Universal Engineer Tractor Crawler is expected to be type classified in fiscal year 1965. Today's system of making contour maps from aerial photographs often takes days of intense eye-straining effort. But a new computer technique now being tested by the Army may soon end the eye strain and speed the process of map making. It's called image processing, and basically it converts pictorial images into numbers for interpretation by a computer. By giving numerical values to the different shades of a photographic grayscale, it is possible to record an aerial photograph as a series of digits. Making accurate, corrected contour maps from a pair of stereo aerial photos is done in this manner. The photos are mounted in an electronic scanning device and scanned by a moving beam of light. The relative brightness of each tiny portion of the photos is read by a photoelectric cell and recorded on tape as a number. The tapes of a 9 by 9 inch photo may contain as many as 10 billion digits. A computer technique known as pattern matching compares the mathematical data of each stereo photograph. Significant points are checked against each other, and the computer mathematically measures their differences. Programmed into the machine are instructions for correcting aircraft orientation and compensation for angular declination. When the computer has completed the photo comparison and checked its calculations, the corrected tape is installed and the entire cycle reversed. Now the scanning device acts as a photo map printer, converting the numbers on the tape back into light intensities and printing them on sensitized paper, which is developed like any other photograph. The result is a highly corrected photo map with contour lines overprinted. The time elapsed less than 2 hours. Making accurate maps from aerial photos by computer marks a big step forward in map-making technology. The preparation of maps and related topographical information are important phases of modern warfare. These operations may soon achieve a maximum of speed and accuracy thanks to image processing by the numbers. Operating under modern concepts of firepower and mobility, artillery units must make gunnery computations quickly and accurately in order to achieve maximum effectiveness. To give the artillery this capability, a small, lightweight, ruggedly built digital computer has been developed by the Army. FADAC, the Field Artillery Computer, Gun Direction M18, solves the most complex gunnery problems in a fraction of the time required by present methods. The M18's capabilities include tube artillery and free rocket type weapons. Roughly only 5 cubic feet in size, this compact high-speed solid-state computer draws its power from a standard 3-phase 400-cycle field generator. FADEC has been engineered for ease of operation. Artillery functions are displayed in standard artillery terms, minimizing the need for special training. A logical interlock prevents canceling of stored programs and ballistic data. Automatic self-checking and the use of error-indicating lights are incorporated to increase overall reliability. These and other safety features prevent accidental interference during solution of a problem. When computing a fire mission, it is only necessary to add variables, such as current metro data, projectile weights, powder temperatures, and other last-minute tactical data. Information about weapon and projectile types, muzzle velocities, drag, and other constants for each weapon have already been entered in FADEC's loading unit, the M36, an ancillary component of the computer. The final bit of information comes from the Artillery Battalion Forward Observer, who radios in the target location. The information is entered, and FADEC proceeds to solve the problem. The gun orders are displayed almost immediately, more accurately and faster than any human could produce them. FADEC provides a big assist in achieving the artilleryman's goal of accurate first-round fire. FADEC can be reassigned from tube artillery to free rockets without any modifying, adapting, or change of hardware. Handling computations for survey operations using the modern gyro orienter and the tellurometer, as well as the more conventional survey instruments, is an easy chore for this computer. FADEC also speeds up fire planning and can provide a series of alternates in a fraction of the time required to produce a single one by present methods. Fast, flexible, lightweight, and simple to operate, FADEC is envisioned as an interim component of the field data system. It is now in initial stages of production for issue to United States artillery units. Regardless of mud, snow, muskeg, or swamp, a new and different type of Army vehicle may soon be speeding delivery of men and supplies. Called PATA, for Plenum Air Tread Amphibious, it operates on a unique principle which provides swift, sure-footed transportation in areas where ordinary vehicles would have tough going. PATA rides on tracks consisting of separate low-pressure air cells, drawing a constant supply of air from a plenum chamber over the lower tracks. A high-volume, low-pressure blower delivers a steady flow of air to the plenum chamber and pneumatic driving tires, and a constant airflow from the plenum chamber keeps tracks free of mud and dirt. A 22-horsepower scaled-down test bed was constructed to evaluate the feasibility of PATA. This one-man vehicle was subjected to a series of rigorous tests. The hill climbing capability included maneuvering on grades as steep as 60%, which PATA easily accomplished. Side slope stability was very good. Tests were also conducted on mud, where ordinary tracked or wheeled vehicles would have bottomed out or been hopelessly mired. PATA's great advantage is that when mud is too soft to support the vehicle, the track's air cells act as flotation gear, preventing it from bellying out. On water, the lower run of the bulky air cells keeps the underbody clear of the surface. The parts of the track in contact with the water push PATA ahead with a speed of about 15 knots. Highway speeds are expected to be in excess of 45 miles per hour. PATA vehicles could add another dimension to our capabilities for overland delivery of troops, weapons, and supplies in swamps, jungle, mudflats, rice paddies, and Arctic areas. The next phase of development is the construction and evaluation of a test bed with 1.25 ton cargo capacity and engineering improvements. This new and improved vehicle's future role in the Army's mission will then be determined. Light, compact, and highly accurate is a new experimental handheld surveillance radar under consideration for development. It will serve to pinpoint enemy infiltration at night, at distances far beyond the range of human hearing or under conditions of poor visibility. The presence of any moving enemy or friendly target is indicated by an audible signal in the earphones. The unit is powered by a battery which supplies sufficient current to operate the set continuously for 12 hours. The entire set, battery included, weighs only 13 pounds. Range to the target is read on a calibrated meter, which is also used to show the remaining effective life of the battery pack and to check other internal conditions of the equipment. Warm-up time is 2 minutes, and the set can be kept on standby and instantly switched to full operation. This permits the set to be ready for action without radiating a signal. A lightweight tripod provides a stable mount, permitting the operator to determine target azimuth within 1 degree. A supplemental A-type display, which can be attached to the basic radar, gives a simultaneous visual signal of all activity within its range. The display reduces continuous operating time by 1 hour and adds 2 3/10 pounds of weight. The 12-inch reflector concentrates the X-band radar energy within a 6-degree arc. A signal will be returned by any moving target within plus or minus 40 yards of the range indication. A running man sounds like this. A Jeep makes this sound. And a tank registers like this. At present, this is an experimental piece of equipment. However, a requirement is currently under consideration for a radar of this type for use by special forces as well as other frontline units. By the fall of 1963, the 1st Army unit will be equipped with 16 of these helicopters, the Chinook CH-47A, for it has successfully passed its flight tests and is now in production. The Chinook has many capabilities that will help the Army to move swiftly, not only in limited and conventional warfare, but also in the event of nuclear war. It can transport the new Pershing missile system, light vehicles, and other large pieces of military equipment. Maximum loads of up to 7 tons can be carried internally or externally slung from a cargo hook below the fuselage. Within a range of 100 nautical miles, it can transport internal loads of 3 tons, 24 litter patients, or 33 troops in full combat gear. A stern ramp makes loading fast and easy. The roomy interior cargo compartment is 30 feet long, 6.5 feet high, and 7.5 feet wide. The rotors are spun by a pair of powerful turbine engines, putting out a total of 4,400 shaft horsepower. Normal cruising speed for this king-size twin-rotored aircraft is 130 knots. Maximum ferry range is approximately 1,000 nautical miles. The new Chinook CH-47A is ready to take its place as a member of the medium transport helicopter units. Its introduction into the Army's inventory will mean a valuable increase in the tactical airlift capability of combat units. These have been highlights from the Army R&D program, a program now coordinated by the Army Materiel Command. The AMC shield represents a centralized authority. It is also a symbol of the unified goal we now have in the Army Logistics program: